into the tools themselves. And businessstory-manager.com is the website for the overall product. And there are some videos there which will explain how requirements and stories can be created and drive the process. So there's more detail on businessstory-manager.com. So let me just introduce very quickly behavior-driven development using current tools, just to give you a sense of how these things work. I've no doubt some of you are already familiar with this, but maybe some of you aren't. So let me just do this fairly quickly. The principle is this: the source of knowledge for a requirement is captured in a story, which is in a structured language. There are several formats, but the most popular, most likely format out there is Gherkin. And the story itself is some structured text, and the text itself would contain a definition of a feature, and there would be a name, and then the feature would be described in terms of as a role of some kind. I want, which is what I want from that feature, what I want to do, so that, or in order that, is the third angle, which is the why I want it. So what the structured story really indicates for a feature is who wants it, what they want, and why they want it. So there are these three dimensions. Now beneath that, there are a whole series of scenarios which illustrate how that feature would be used. And the structure of those clauses in a story, if you like, has a pattern of given, when, then. Given some situation, some current state, is the first clause. When the user does something, some event occurs. And then the third aspect is the then clause. What is the outcome of the current situation plus some kind of stimulation to the software? What is the outcome? So given, when, then are like preconditions, steps, and postconditions. In many respects, it's like a test case in the traditional way you might think of test cases. So scenarios are completely familiar to testers and the way that they think in terms of, now, business stories are written in business language and they relate directly to requirements. So they're not executable as pieces of software, but they are understandable as examples of features in use. So because they're in business language, they are still recognizable by users and stakeholders, but they need to be transformed into formal test cases if you're going to automate them. And I'm going to walk through that process now. So in the diagram you can see this the story, and we take a BDD tool, and the most popular, the best known I think is Cucumber nowadays. But there are quite a few others now, maybe six or even more now. JBehave, RSpec, SpecFlow, and others have a BDD kind of component. What the BDD tool does is it interprets the text of the story and generates what you would then recognize as some test code. So with Cucumber, it uses the Ruby language, so it actually generates some Ruby code. Now, that's great if you're a Ruby programmer, but not so great if you're not a Ruby programmer, okay? But let's move on anyway. So the BDD tool generates some test code, which looks like some automatable test code. However, you still need the fixtures or test step definitions to connect the test code that's generated to the system under test. Obviously, a story might say, the user confirms a transaction on a screen maybe. Well, that's not enough information to identify a button that must be clicked on a web page. So the test fixtures provide that kind of definition. Where there are keywords used in the story, the fixtures, keyword definitions, test step definitions provide the translation into some physical activity on the system under test. So okay, so now we've got some generated test code. We create our test fixtures, test step definitions, keyword definitions, whatever. Different technologies have different names for these things. And we can execute the test on the system under test using the BDD tool or a library that is connected to the BDD tool. So this could be a Selenium library, or it could be a library to drive Windows, VB applications, that kind of thing. And there are many libraries out there now to test almost every platform you can imagine. So we can run a test which generates test outcomes. the developer who is taking these tests and running these tests knows that when they run them the first time, they will fail, of course, because the system under test, the feature under test, does not yet exist. So what the process becomes is the developer runs the tests, looks at the outcomes, and then creates code, writes code, and manages and edits the code to pass the tests. So this kind of cycle of activity of test fails, change the code, run the test passes, this cycle evolves, allows the developer to evolve the software itself. Now these tests are checks, if you like. They are not very sophisticated tests. Let's not get too carried away. They're not end-to-end tests. They are very much focused on the features and the development. But the notion of test automation at a feature level, at a story level, allows developers to adopt the test-driven approach. So the nature of this would be the test. When the tests pass, the developer then, you would expect, to refactor the code. So as the code evolves to pass all the tests, usually there's a final phase of development to refactor, to redesign, to tidy up loose ends and so on and so forth, and make the code slightly of higher quality. But the tests themselves provide a regression safety net, if you like, for them to do this. So BDD at the moment works this way. Now the benefit to developers is they can use it to drive the test-driven approach. But what BDD provides essentially is it allows the collaboration between business stakeholders, testers and developers and analysts to derive requirements that have meaning, and the transformation into test code is something that the technical people can do. So this encourages the collaboration in an agile project, but it's kind of universal. It's emerging as an opportunity for all project types. Now the beauty of using structured stories, which are recognizable by business users in business language, in their domain-specific language, is that it encourages the developers to write their test code and to write the software using the same, if you like, words and names for entities and functions and features as was used in the requirements. So BDD encourages the use of domain-specific language right throughout the requirements through to code. And the buzzword that you'll hear quite a lot about, increasingly I think, is this concept of ubiquitous language. That is, the language used in requirements could be recognized even down to the code level. And this kind of encourages better communication throughout our project between business people and technical people. The problem is that the current tools only really support the test automation side of this process. They don't really provide a lot of support to the collaboration side between the business analysts, testers and developers. So what we've been promoting for a couple of years now is an approach which is broader than the rather limited BDD approach, to say, well, wait a minute, non-trivial systems need a set of requirements that are more comprehensive, the business rules themselves, that are more comprehensive than just stories. And our argument, which I can't go into too much detail now, but our argument is that you need requirements and you need stories. And the stories provide two major benefits on top of the requirements. Firstly, they example and illustrate the requirements so they can be used as a feedback mechanism to validate requirements. And when the requirements and the stories are aligned and there's comfort that the requirements and stories are accurate, those stories can be reused to drive the behavior-driven approach. So in Business Story Manager and this story platform for QA, which is what I want to show you, we have a requirements module which allows you to create textual requirements formatted in any reasonable way, and provides a hierarchy of requirements too. Now beneath that we can create stories which identify features which are aligned with those requirements. And it's arguable whether the requirement comes first and then the story comes along second, or the story comes first and the requirements are derived. It's kind of cyclical and iterative. In many ways, users will tell you a story when you ask them what they want, but to capture the rules of the process that they describe in their stories, you need a more formal language and a defined business rule to provide the generalizations that stories quite often don't give you. So requirements and stories are fundamental to what's in the product. We also have a module which manages a thing called the dictionary, which I'm not going to go into detail about, but it basically holds, it registers all your terminology, a glossary of your terminology, and indexes the use of that language in requirements, in stories, and in scenarios, and therefore tests. So the dictionary provides a navigable index, a bit like Google for your requirements, for your knowledge base. Okay, so that's what the dictionary does. I can't talk about that today, another day, I think. So, okay, so we have our structured stories, and we have a feature to export those stories in a range of formats. Okay, initially, we're looking at generating test cases in a format that Robot Framework would recognize. So in effect, what we've got is we have a requirements hierarchy, stories aligned with individual requirements, scenarios which example the features in those stories, and those scenarios can be exported in a format that Robot Framework would recognize. Now, just like the BDD process I showed you a couple of slides ago, the test cases in Robot Framework format require definitions. So we have a resource file, typically, which provides the translations of keywords into, in effect, Selenium or WebDriver kind of commands to drive the system of the test. The beauty of Robot Framework is it has a WebDriver Selenium library for handling websites, but there are many other libraries, and that's why we found it attractive to look at Robot Framework initially. Now, once the test cases exist, the keyword definitions exist, you can run your tests against the system and the test. Now, in principle, we have exactly the same process. We have a series of outcomes and outputs and a status of all our tests to allow developers to build the product, but also we're building a platform, a regression testing platform, as a natural outcome of working with requirements and stories in this way. Now, the output of those tests, once the software is trusted and passes the test, we can pass that status back into SP.QA. So we can report progress against individual scenarios, stories, and requirements in SP.QA. So we can connect, and we have that feedback loop between tests run at a relatively low level against requirements